So far, we've learned how to differentiate a variety of functions, including trigonometric, inverse, and implicit functions. In this section, we're going to explore derivatives of exponential and logarithmic functions. But before we do that, we need to recall the properties of exponents and logarithms. These are expected for you to know, so please make sure that you spend some time to go through these. Maybe write them on a note card so you can have it handy as you're working out problems to recall these as we're working through these problems. These properties are going to come in handy when we're evaluating derivatives of both exponential and logarithmic equations. So the derivatives of inverse trigonometric functions, and if you're wanting to find the proofs over these, they're pretty cool. You can find the video of them by clicking on the link in the PDF of these video notes. So to find the derivative of the natural log of x, so that is 1 over x. The derivative of log base b of x is 1 over x natural log of b. We've already learned the derivative of e to the x. We know that is just e to the x. But if we have the derivative of b to the x, so if we have the derivative and instead of this being the number e, because remember e is a number, so if this was something other than the number e, so like 3 to the x, 5 to the x, then the derivative for that is b to the x natural log of b. So let's find the derivative of f of t equals the natural log of t to the 7th power. So we're going to do this in two ways. First way is I can look at this and say, okay, well, I'm going to have to use the chain rule. I have an inside function that I can evaluate, and now I know how to evaluate the logarithmic function. So let's use the chain rule to do this. So if I use the chain rule, the derivative f prime of t, so that's going to be the derivative of the outside function. So the derivative of the natural log function is 1 over the input. And in this case, we have to evaluate it at the inside function. So it's, instead of it being 1 over t, it's going to be 1 over the inside function, which is t to the 7th power, times the derivative of the inside function. So again, just using that chain rule. Derivative of the outside evaluated at the inside times the derivative of the inside. So that's going to give me 1 over t to the 7th times 7 t to the 6th power, which is going to end up simplifying. We get 7 t to the 6th over t to the 7th, and then I can use those properties of exponents, and that's going to simplify down to 7 over t. Now, here's the cool thing about logarithms. So we have those logarithmic properties that we learned on that second slide. So one of those properties said if you're taking the logarithm of something to a power, you can move that power in front. Same thing holds true with the natural log, because recall that the natural log is just log base e. So what I could do if I didn't want to apply the chain rule, another way we could do this is we could simplify this function first using properties of logarithms and then find the derivative. So I can use this property to move that 7 in front. So instead of it being a power, now it becomes a factor, and that's just using the properties of logarithms that we learned in college algebra. Now this is a much easier function to find the derivative of, because this is just taking that derivative of 7 natural log of t. So again, when you're taking the derivative, if we've got a constant, you can move that constant out in front. So it's just going to be 7 times the natural log of t, the derivative of the natural log of t, which we found the derivative of the natural log of t is 1 over t, so we just get 7 over t. So hopefully you're able to see, and I definitely added more steps than you probably needed for this, all the steps in green. But you can see it's a lot simpler if we can first simplify our function using properties of logarithms before we find the derivative. We're not going to end up having to use that chain rule. All right, find the derivative of f of x equals the natural log of this entire thing, x squared times the sine of x all over 2x plus 1. Holy moly, guacamole. So we are taking, if I were to do it just as is, this is going to be having to apply the quotient rule or the chain rule because I have something inside. And then I'm going to, with finding the derivative of the inside, I'm going to have to use the product rule, I'm going to have to use the quotient rule, and it just can get super ugly. So this is the great things when we're doing these derivatives of log functions, is we can apply the properties of logarithms to simplify this function before I go through and find that derivative. So if I'm going to simplify this up, I'm just going to write over here those properties that I'm going to use. So if you have two things multiplied together, you can expand that out using that product property. And then we also have the quotient property of logarithms. If you're dividing two expressions, we can expand that out by finding the quotient, using that quotient rule. And then again, this power rule is, I think, one of the most powerful ones for logarithms. Okay, so I'll call this 1, 2, and 3. So let's first, before I take the derivative, let's first simplify this out. So I'm going to first apply the quotient rule, so property 2, because I've got the logarithm of two things. So I've got this divided by this. So let's use that to simplify this. So this becomes the logarithm, so the natural log of x squared sine of x minus the natural log of 2x plus 1. Now I can use that property 1 to expand this first term out because I have two things getting multiplied together. So this will expand out to the natural log of x squared plus the natural log of sine x minus the natural log of 2x plus 1. And now I'll use that third property to move that power, that x squared, out in front. And at this point, I can't simplify this anymore using properties of logarithms, although I'd love to be able to write that last term as the natural log of 2x plus the natural log of 1. I don't have a formula that I can use to expand that out. So that's kind of stuck in there. The only time you can expand logarithms is if we're multiplying what's inside or dividing. All right, but now this is a much simpler function to find the derivative of versus this craziness. So if I were to find this derivative, again, we're finding the derivative of each piece, and now I'm only having to apply that chain rule twice. I'm not having to use the product rule and the quotient rule as well because I've expanded this all out. All right, so first one, the derivative of 2 ln of x, so that's going to be 2 times the derivative of the natural log of x, which is 1 over x. All right, I'm going to have to use the chain rule for this next one because I do have an inside function. So the derivative of the outside function, the derivative of the natural log, is 1 over x, but I'm using the chain rule, so it's going to be 1 over the inside function because I have to evaluate it at the inside function, times the derivative of the inside function. So the derivative of sine of x is cosine of x. Okay, and then that's going to be minus. All right, so again, I'm going to have to apply that chain rule because I have an inside function. So the derivative of the outside function, which again would be 1 over x, but I'm using the chain rule, so I have to evaluate it. So instead of x, it's going to be whatever the inside function is, times the derivative of the inside, which is 2. So that gives me 2 over x plus cosine of x over sine of x minus 2 over 2x plus 1. And I can rewrite cosine over sine is just cotangent. And then at that point, we're done. If I were to have gone through and done the derivative, and if you want to, I really recommend you try to find this derivative using the chain rule without expanding it out first, and you'll see how many more steps there is and how it gets so much more complicated than if we use these properties of logarithms first to simplify it by expanding it out into much simpler terms to take the derivatives of. Okay, let's try another one. So I've got the natural log of e to the x over the square root of 4 minus x. So let's again go through and expand this out. So we're starting with the natural log of e to the x over the square root of 4 minus x. So I'm first going to use that quotient property, so that becomes the natural log of e to the x minus the natural log of the square root of 4 minus x. I'm going to keep on going, and that's because I can use that product property, and this, or sorry, I'll first use the power property so that x can come in front. Now I can rewrite the square root as something to a 1/2 power. So taking the square root is the same thing as putting it to the 1/2 power. And by doing that, now I get rid of that square root. So really quickly, the natural log of e is 1. So that just, now I've got x times 1, which is x. So that's made that a lot simpler. That's going to be very simple to take the derivative of. And then minus 1/2 times the natural log of 4 minus x. Okay, so now that we've simplified this out, now we can actually go through and take that derivative. So the derivative of the function is going to be the derivative of that first piece minus the derivative of the second piece. All right, so this first one is just 1. Sweet. Okay, I'm going to move that 1/2 out front. So now I'm taking that derivative of the natural log of 4 minus x. So again, I'm going to have to apply that chain rule. So the derivative of the outside is 1 over x, but in this case it's 1 over 4 minus x because it's 1 over the inside function, times the derivative of the inside function. So the derivative of 4 minus x is -1. So that's going to give me, I'm going to put this over 1 and we can multiply these fractions through. So that's going to give me 1 minus a -1 over 2 times 4 minus x. Subtracting a negative is the same thing as adding, so we're going to get 1 plus 1 over 8 minus 2x. And you're done.